Hello, this is Dr. Donna Burnett. In this lesson, we will consider Chapter 4, Food Safety. Let's get started. By the end of this chapter, you should be able to define foodborne illness, summarize the major biological hazards, explain the causes of food infections, list and describe the major food intoxicants, identify and describe bacterial toxin-mediated infections, compare and contrast harmful chemicals and objects in food, define the differences between food allergy, intolerance, and sensitivity, provide several steps in preventing foodborne illness, and understand the proper use of food thermometers. The U.S. food supply is probably the safest in the world. This is because the United States has food safety as a priority. The CDC tracks down causal factors for outbreaks of foodborne illness, and the FDA and USDA monitor the food supply. We also have a food defense where we protect against food terrorism. Of outbreak, which is the occurrence of 2 or more cases of a similar illness due to the ingestion of a common food. Foodborne illness is defined as an illness transmitted to humans by food. Symptoms of foodborne illness could be nausea, abdominal cramps, diarrhea, and vomiting, among others. And the severity is based on what was ingested, how much, the age and immune system of the person acquiring the foodborne illness, especially the very young and the elderly. Because of the loss of fluid, this can lead to dehydration, hospitalization, or for this or other reasons, even death. The 3 major categories of foodborne hazards are biological, chemical, and physical. And we'll get into each of these as we go. Let's start with biological hazards. Biological hazards would be living culprits, including bacteria, molds, viruses, and parasites. Some of the common pathogens are Campylobacter, norovirus, and Salmonella. As we will see throughout this lesson, prevention methods will include adequate cooking to kill harmful microbes, which will mean cooking to a safe temperature, and then proper cooling to get that food in the safe temperature range quickly. Over 90% of foodborne illnesses are caused by bacteria, with only 4% being pathogenic. Types of bacterial foodborne illnesses would be foodborne infections, food intoxication, and toxin-mediated infections. Again, we have categories to help you understand. Food infections would be caused by ingesting the bacteria that would then grow and colonize the intestine, whereas food intoxication or food poisoning would be from ingesting toxins that are produced by the bacteria in the food. And finally, toxin-mediated infections would be bacteria producing toxins within the intestine after ingestion. So those are 3 different modes. Table 4-2 groups the biological hazards according to severity of risk. You have your severe hazards, your moderate hazards that have the potential to be more extensive depending on the age of the person who acquires the foodborne illness, also any complications that might occur. And then you have your moderate hazards, which would have limited spread. So in the severe hazards, you might recognize hepatitis A and E, for instance. In the moderate hazards, you might recognize rotavirus. In the moderate hazards, limited spread, you might recognize Bacillus cereus. Again, I'm not going to read every name. It makes for a very boring lecture, and you won't remember it that way anyway. You're going to need to refer back to your tables in your textbook or rewatch this lesson or a combination. Table 4-3 breaks out some of the bacterial food infections. And here we see the causative agent, the latency period, which is how long it takes to develop the symptoms. The duration would be how long it lasts. Then you have principal symptoms, typical foods, mode of contamination, and prevention of the disease. You will see several tables here in a row. Again, I won't read every single line. I want you to look for commonalities, and then at some point in time, you will be probably responsible for either knowing examples or categories, whatever your teacher of record requires. So let's look at just a couple here. Let's look at Salmonella species. The latency period would be 12 to 36 hours, meaning let's say you ate lunch at 12 o'clock at noon, 12 o'clock midnight, you might start experiencing diarrhea, abdominal pain, chills, fever, vomiting, dehydration. If you've ever had foodborne illness, you know what I'm talking about. It could be it can happen rapidly. It might take some time. Here, up to 36 hours. You might not even remember what you ate at that point. It's one reason it's very difficult to track these down. Okay, your typical foods you might see for salmonella as a causative agent would be perhaps raw or undercooked eggs. This is why we cook our eggs. Raw milk, meat or poultry, fresh produce. And if you look at the mode of contamination, infected food source animals or human feces, and you'll see this as a commonality on this table. How would you prevent the disease? You would cook your eggs, meat, and poultry thoroughly and up to the proper temperature, pasteurize milk, irradiate chickens, thoroughly wash produce. Now, a few points to here. Want to point out if you were to say go to a restaurant and let's say you ordered a hamburger and you ordered it medium well, that would have to come with a caution on that menu somewhere saying that you do so at your own risk because the restaurant can't guarantee that you won't acquire a foodborne illness unless they're allowed to cook the meat up to well done. Same with eggs. If you order over easy, sunny side up, anything besides cooked eggs that are cooked thoroughly until their proper temperature, then they can't guarantee you won't get sick. And so you'll see that on the menu at the bottom in a little asterisk. Now, I just pointed out one here, but I want you to now look down the columns. You'll see the latency period is pretty similar, except maybe that last one could be up to 7 days. Listeria could be up to 70 days, which you would never remember what you ate at that point. The symptoms, most of them are pretty similar with diarrhea, fever, vomiting, nausea, cramps, except the first one is going to have more severe symptoms of perhaps meningitis in newborns. You might even see stillbirths because of this, septicemia. That's would be considered obviously a severe risk. And what do we see as typical foods? Raw milk, soft cheeses, vegetables, deli meats. If you look across at the mode of contamination, soil or infected animals directly or via manure, and how you prevent this would be pasteurizing the milk or cooking the food. But I want you to notice this. It's not just infants that would be affected. Anyone could be affected here. And the thing that you'll notice is that what about the category of vegetables? That's a huge category. So this is one reason that we have to be very careful about cleaning, especially lettuce or vegetables that grow close to the soil. And think of how lettuce grows. Dirt is actually in that core of the lettuce. So this is why we peel off the leaves of the lettuce and we take out the core. We wash each leaf of the lettuce carefully, and we don't take anything for granted that it's going to be clean unless we clean it. Now, you might find lettuce packaged, like pre-packaged for salad, and that's all carefully washed. You don't have to rewash that if it says ready to use. Table 4-4, now we're on to bacterial food intoxications. So this is a little bit different. Let's take the last one in this row in this chart, Clostridium botulinum, which is botulism. That's one that you probably would recognize. The latency period, 12 to 36 hours, but the duration could be months. And look at the symptoms here: fatigue, weakness, double vision, slurred speech, respiratory failure, sometimes death. And in this chart, you're going to see that's a little different than the other two causative agents, Bacillus cereus, where you have a diarrheal type and an emetic type, which we'll talk about. And So you'll see a little bit of a difference in the symptoms. Look at the typical foods. We have meat products, soups and sauces, once again, vegetables, cooked rice and pasta. For both types of botulism, you have potential problems: vegetables, fruits, meat, fish, poultry products, condiments. For type E, fish and fish products. Those are very general categories: vegetables, fruits, meat. So, again, we have to be careful with all the foods we're preparing. Your mode of contamination here would be from the soil or dust, which tells you you're going to have to make sure the food is cleaned when it comes out of the soil. You also could have, for type E, the water could be toxic. And how do you prevent this disease? As you'll see repeatedly, thorough heating and rapid cooling of foods, especially homemade canned foods for the last one, for botulism. Table 4-4, this is a continuation of bacterial food intoxications. Here's another botulism. Here we have infant botulism. The latency period is unknown. The duration is unknown. The symptoms are a little different. We have constipation, weakness, respiratory failure, sometimes death. Typical foods: honey and soil, which means the food isn't washed or you wouldn't be ingesting soil. And here you have the idea that you do not feed honey to infants. That's something that you learn in nutrition. Up to the age of 1, infants don't have the immune system to handle the spores that could be found in honey. You have Staphylococcus aureus, and these have some similar characteristics. How you prevent the disease: for infant botulism, you do not feed honey to infants. And the other two here, thorough heating and rapid cooling of foods. And the idea is to have the food in the safe temperature range, either hot or cold, but not lukewarm. And we will get into those details of those exact temperatures as we go through. Table 4-5, we have bacterial toxin-mediated infections. Again, the causative agent, the latency period, the principal symptoms, typical foods, mode of contamination, and prevention of disease. Let's look at E. coli here. So there's actually 3 types of E. coli. Let's take the enterohemorrhagic. The latency period of 12 to 60 hours, which again is a very long latency period, and the duration could be 2 to 9 days. For E. coli, enteroinvasive, uncertain duration. And then that last category, the latency period could be 10 to 72 hours, and that could last 3 to 5 days. But what do we notice here in the principal symptoms? When we look at the principal symptoms, we see some commonality here with diarrhea, abdominal pain, fever, nausea, cramps, dysentery, watery diarrhea. So these are pretty similar, affecting the intestinal tract. Your typical foods would be infected food-sourced animals, raw or undercooked beef, raw milk, raw foods, raw foods. Well, that's a lot of different items to be raw food. And this is because the mode of transmission or contamination is going to be human fecal contamination or infected cattle or chicken or raw milk. But when you look at the human fecal contamination, which again, you're going to see repeatedly, how could that be? Well, here you have direct or via water. And this is where contaminated water becomes a problem. When sanitation in an area isn't good, or they're dumping raw sewage into water that's then used, that people use, you're going to end up with this potential. How do you prevent the disease? You cook chicken thoroughly, you avoid cross-contamination, irradiate chickens, pasteurize milk, cook beef thoroughly, cook foods thoroughly, general sanitation, and the same. Again, commonalities: cooking thoroughly to get it into a safe temperature range. Table 4-5, bacterial toxin-mediated infections continued. Here we see some additional causative agents And again, the profuse, potentially watery stool, sometimes vomiting, dehydration, uh, diarrhea, cramps, sometimes nausea, vomiting, fever, headache, chills, fever, prostration, often death. And these are causative agents that are found in a marine environment, one being cholera. If you let's take that one for an example. So you have the latency period of 2 to 3 days, and then the duration up to 7 days. This can be very serious, as you see here. It can be rapidly fatal if untreated. Typical foods would be raw or undercooked seafood. The mode of transmission would be human feces in a marine environment. Again, raw sewage being dumped. How you prevent this? You cook seafood thoroughly, and of course, general sanitation. I just want you to pause and think for a moment about what happens when you possibly eat raw seafood. Some people do eat raw seafood in whether it's oysters or sushi, and you have to wonder, how does a restaurant uh, prevent foodborne illness in raw seafood if that's a high risk agent? Well, they have to do something. So, as we will learn momentarily, if you can't cook the seafood, you have to freeze it. You have to freeze it at a low enough temperature that any microorganism present would be killed, rendered ineffective. So, that's something you need to know. And this is why, even in high end restaurants, sometimes they'll have a chef that's trained to look at some of these under a microscope to see if there's any active bacterial potential for toxin mediated infections. Figure 4-5 shows the pathway of how E. coli can cause serious health problems. We know that E. coli is naturally found in the intestinal tract and causes problems only when fecal matter gets into the food or water supply. So if you look to the right of your screen, you'll see at the top we have bacteria that naturally lives in the intestines of healthy humans and animals. Most strains are harmless or even beneficial, but some, such as E. coli, can be harmful, even fatal to humans. So how does this get introduced into the food supply? Well, if you let's take beef for instance. You have a cow. The carcass meat may become contaminated during slaughter if the intestines are accidentally cut and the contents touch the muscle, which is the meat that you're going to eat. Then someone fails to thoroughly cook the ground beef, and that allows the bacteria in the center to survive. Ground beef is used as an example here because that's particularly problematic because ground beef has to go through a grinder, and that may or may not be cleaned properly or often enough throughout a work session. If it's a whole piece of meat like a steak, you're less likely to have a problem. You have the same warning if you choose to eat meat that's not fully cooked. Okay. So let's go back to our ground beef example. That's really problematic. So the person consumes the hamburger, let's say. The bacteria live then in the human's large intestine and produce toxins. Now you can have two types of symptoms, and that's what we call A. We have the A, an example A and B. A would be hemolytic colitis, where we're having symptoms in the intestinal tract, severe abdominal cramps, vomiting, fever, bloody diarrhea. B, the hemolytic uremic syndrome. Now you have bacterial toxins destroying red blood cells. That may clot the kidney's small blood vessels, and this can lead to acute renal failure in children. It can even result in death. Let's talk about molds. Molds produce mycotoxins. Molds are visible, unlike bacteria on food. Foods with molds in general should not be eaten, although there are some exceptions like blue cheese. Other foods like soy sauce depend on healthful molds. Now, a hard cheese like Swiss or cheddar cheese can be cut 1 inch from the mold and can still be used. But soft cheeses like cottage cheese or cream cheese cannot be used once they have mold because the mold can penetrate that cheese. You can't really cut it away. Viruses require a living cell to multiply. They're spread primarily via the oral fecal route, contaminated water, and direct human contact. Some of the key viruses and foodborne illnesses would be hepatitis A and norovirus. We're going to talk a lot about the oral fecal route, and you will come to appreciate why food service employees must wash their hands. They wash their hands in that restroom, and then they come out in the kitchen and wash their hands again in the hand washing sink. Hepatitis A virus spreads through food contaminated with fecal matter. It's linked to polluted shellfish and contaminated vegetables. And again, the fecal matter could be from an animal, wherever the vegetables are grown. Norovirus is the leading cause of gastroenteritis in the US, and it is spread through contaminated food handlers and shellfish. It's destroyed by heat but resistant to freezing. Table 4-6 shows viruses causing foodborne illness. Let's take hepatitis A, for example. The onset, 10 to 50 days. That's a long period of time. You might not be able to trace that back. Duration, 2 weeks to 6 months. Principal symptoms, fever, weakness, discomfort, nausea, often jaundice. Typical foods, raw or undercooked shellfish, sandwiches, salads, often which are not cooked at all. Mode of contamination, human fecal contamination via water or directly. Prevention of the disease, cook shellfish thoroughly. And general sanitation. This is where we talk about hand washing. In a food service, there are protocols where an employee washes their hands in the restroom after using the restroom. There have to be adequate supplies in the restroom for them to do this properly. Then they come out and they wash their hands again in the hand washing sink in the kitchen, which is usually near the restroom. Why do we have them wash their hands in the kitchen after they've been in the restroom? Well, that's to guarantee they wash their hands. You can't follow them in the restroom, and you have to have some way to guarantee they wash their hands. And this should be monitored by the supervisor to make sure people coming back into the kitchen, really from wherever they might have left to go, whether they're delivering trays or anything, they should wash their hands when they come back in the kitchen. You see noroviruses and rotaviruses, they have shorter onsets, shorter durations. They're not quite as severe, but they also have in common the mode of transmission is through human fecal contamination. And how you prevent those would be, again, cooking shellfish thoroughly and general sanitation. Parasites would be another category. Parasites need hosts to survive. We will discuss here roundworms and protozoa, principal symptoms, typical foods, mode of contamination, and prevention of disease. So this is a different category. When I say different, it's very different. So here you have mode of transmission, larvae encrusted in animals' muscles, eggs in soil from human feces, and larvae that occur naturally in edible parts of seafood for the roundworms on this table 4-7. The onset can be 8 days to 15 days, 10 days to 8 weeks, hours to weeks. Principal symptoms also differ. You have muscle pain, swollen eyelids, fever, sometimes death, sometimes pneumonitis, bowel obstructions, because again, these are roundworms that are growing in the intestinal tract. Abdominal cramps, nausea, vomiting. Again, we're going to have raw or undercooked meat, raw vegetables or fruits that grow in or near the soil, raw or undercooked marine fish, squid or octopus. But how do we prevent this? Thorough cooking of meat, freezing pork at 5 degrees Fahrenheit for 30 days, or irradiation. Sanitary disposal of feces, of course, cooking food, cooking fish thoroughly, or freeze at -4 degrees Fahrenheit for 30 days. So you see in each of these species, you have similarities, but a few differences. Table 4-7 continues with parasites causing foodborne illness. You see your causative agent these are going to be protozoa, and you have several species. The onset and the duration can be for Giardia up to 25 days of onset, and then varied amounts of duration. Principal symptoms are, you see some commonalities here, but a few differences as you look down the column. Typical foods would be Mishandled foods. So that's everything. Raw or mishandled foods, raw or undercooked meats, raw milk, mishandled foods. And then that last category, I want to point out that's a new addition to the textbook for this edition. And this would be rat lung disease, that you would see this in Hawaii, Southeast Asia, Pacific Basin, Sub-Saharan Africa, with snails and slugs. These are typical foods. Aquatic prawns, frogs, water monitor lizards. And the mode of contamination here, leafy greens carrying larvae that are not completely washed. How do we prevent this disease? General sanitation, thorough cooking, pasteurized milk, and then that last category, cautiousness with typical foods, which are the snails and slugs, etc. Do not handle snails. Thoroughly wash greens, especially romaine lettuce. Continuation again, table 4-7. Now we're looking at tapeworms. If you see the same columns, you have your onset, 10 to 14 weeks. In that last category, the pork tapeworm. So you have beef tapeworm, fish tapeworm. The last category is pork tapeworm. 8 weeks to 10 years of onset. And the duration can be 20 to 30 years. And that's for all of these tapeworms. Principal symptoms: seeing worm segments in your stool, but sometimes you'll have digestive disturbances. For the fish tapeworm, limited symptoms, but sometimes you'll see a vitamin B12 deficiency. The pork tapeworm, worm segments in the stool, sometimes you'll see cysticercosis of muscles, organs, heart, or brain. Typical foods here we see raw or undercooked beef, raw or undercooked freshwater fish, raw or undercooked pork, or any food mishandled by a T. solium serum carrier. And the mode of contamination, larvae in the beef muscle, plerocycoids in the fish muscle, larvae in the pork muscle, also human feces with T. solium serum eggs. How do you prevent this disease? Cook beef thoroughly or freeze below 23 degrees Fahrenheit. Heat fish 5 minutes at 133 degrees Fahrenheit or freeze for 24 hours at 0 degrees Fahrenheit. Cook pork thoroughly or freeze below 23 degrees Fahrenheit. And general sanitation. Okay, the last category here would be prions, mad cow disease. So prions are misfolded proteins associated with transmissible, spongiform encephalopathies, TSEs, such as mad cow disease. TSE attacks brain tissue. It's believed to spread to humans through the consumption of infected cattle. The USDA has tight regulations to prevent outbreaks of mad cow disease. And we see this through CDC's PulseNet, where they have a system of monitoring foodborne pathogens, including prions, where these can be reported and then monitored. Let's move on to chemical hazards. Harmful chemicals in food would be substances hazardous to health from additives, plant and animal toxins, and metals. Toxins in seafood can cause foodborne illnesses even after cooking. And here are some specific seafood toxins. You can see ciguatera poisoning caused by tropical fish containing ciguatoxin, histamine food poisoning, puffer fish poisoning, and red tide. Table 4-8 shows some food additives that would be unintentional: pesticides, herbicides, fertilizers, pharmaceuticals in the water supply, which we do see in the groundwater from people discarding unused pharmaceuticals in the water. Industrial chemicals, pollutants, cleaning products. You always store cleaning products under a food preparation table in a kitchen, never above it where they could potentially fall into the food. You have plant toxins and animal toxins and toxic metals, heavy metals such as arsenic, lead, cadmium, mercury, and other metals. Under plant toxins, you see raw or undercooked red kidney beans, certain mushrooms, certain herbs, fruit pits, mold toxins, which we already talked about, and then animal toxins. Mostly here we're talking about seafood toxins. Physical hazards. This is our last category. These would be objects found in food that are not supposed to be there and can harm consumers' health. Hair is the number one hazard. Glass, bone, metal, especially when you open cans with a can opener, those metal shavings can fall back into the can. You have to be very careful there. Wood, stones, false fingernails, toothpicks, watches, jewelry, insects, staples from food boxes, and any other thing that is in the food that should not be there that can harm a consumer's health. Let's shift our focus now to understanding food allergies, intolerances, and sensitivities. Definitions. Food allergy is an immune response to specific proteins in food. Food intolerance, non-immune response due to enzyme deficiency. Food sensitivity would cover allergies, intolerances, and any other adverse reaction. The Food Allergen Labeling and Consumer Protection Act mandates clear labeling of allergens and food products. However, these allergens vary by country. How do we prevent cross-contamination? Well, first of all, let's say it's critical for preventing allergic reactions. So you go to a restaurant and they serve seafood, you have a seafood allergy. They also serve steaks and chicken and other things. So you go there and you order a steak. Let's say someone in the kitchen used a cutting board that they had previously used for seafood, and now they used it for something they're putting in the dish or your steak. They cut a steak on it. Very possible that person would have an allergic reaction. I've seen it happen. USDA regulated products, meat, poultry, eggs, must include allergen information. Manufacturers must document allergen control in their standard operating procedures. Here's the table I was talking about, table 4-9, showing you what must be labeled in various countries. So we have our US mandated tree nuts, peanuts, soybeans, eggs, milk, fish, wheat, sesame, and shellfish. It's a little different in other countries, and you can look across this table and see the differences. At any time, you can always pause the video and review a little bit more, or you can look in your textbook. Well, so how can we prevent foodborne illnesses from originating? And mostly this happens in restaurants. So let's talk about the restaurant environment. First, you must train food service personnel in food safety. We have various levels of training. You have food handlers, that would be people who just handle the food. You have food protection managers. ServSafe has a program that would be for the manager of the restaurant, and they would ensure that the food service personnel were adequately trained, or they require food handler cards, but they also need recurring training. Personal hygiene habits, avoid hand to mouth. So this is why there's no eating in the kitchen, there's no drinking, obviously no smoking, but anything that could cause someone to have their hand touch their mouth and back to the food. Hand washing, proper gloving, and clean uniforms. We'll talk about each of these. I especially want to point out proper gloving. Anyone who touches food that will not then ever be cooked must wear gloves. So salad makers, anyone making sandwiches, anyone in the cold food area, that food will never be cooked. So it always has to have, those workers always have to have gloves. When you train your food service personnel, these are some of the areas they need training. Obviously, personal hygiene. And the most important thing here would be report to the supervisor if you are sick. Food workers with either vomiting, diarrhea, or jaundice are excluded from work unless they have no symptoms for 24 hours or a written release from a physician. Jaundice cases must be reported to regulatory authorities, which will be your health department. Over in food handling, avoid handling food directly. Use serving spoons, scoopers, dippers, tongs, and ladles. Cover all exposed food with lids, plastic wrap, or aluminum wrap. Food does not leave the kitchen without it being covered. Anytime trays are delivered or any floor that needs food, it has to be covered. You can't take food out of the kitchen without it being covered. If you taste food, which cooks need to taste the food, you use a 2-spoon method where you have one spoon that you're going to taste from, and the other spoon is like a dipper, and you dip the food onto the spoon you will use to taste from, and that way you don't double dip. When gloves are used, they need to be changed between food and non-food handling. In the kitchen, employees should wash their hands in the hand washing sink before starting and after breaks and meals. When they cough or sneeze, they should be trained to sneeze into their upper sleeve or elbow, mostly, or a tissue if they're not standing directly where they're cooking. They would discard the tissue, wash hands often with soap and water for 20 seconds. No smoking, gum chewing, eating, or drinking. You don't want to get that saliva into the food. Keep all surfaces clean. There's some specific rules about how to do that. And then for serving, hold plates without touching the surface. Carry silverware only by the handles. Handle glassware without touching the rim or the inside. Another way you can prevent foodborne illness is by following the flow of food through the facility and ensuring that it's handled properly at each point. It starts with purchasing from safe food suppliers all the way to delivery, inspection, proper storage, and then making sure that foods are stored at the proper temperature under 40 degrees or over 140 degrees Fahrenheit. There are some slight variations depending on what authority you're talking about. The USDA suggests 40 and 140. So anything between that range, between those numbers would be an unsafe temperature range. Figure 4-9 is an illustration that helps you remember the points within the process where you can have some problems with food safety. The food itself, the time it is in the safe temperature range, outside of the safe temperature range, and what those ranges are. So for consumers, we already have learned the USDA recommends 40 degrees Fahrenheit to 140 degrees Fahrenheit. That's an unsafe range. So safety would be below 40, above 140. For restaurants, it's a little narrower. So the safe temperature range here would be 41 degrees and lower and 135 degrees Fahrenheit and higher. Next, we're going to look at proper storage of food in the safe temperature range. So if you want your food to be in the safe temperature range, you have to monitor your refrigerators and freezers to make sure they're operating properly. You want to maintain your refrigerator at or below 40 degrees Fahrenheit. You want to maintain the freezer at or below 0 degrees Fahrenheit, and not to overload the refrigerator or the freezer or put large amounts of hot food in either. That will cause a dangerous temperature fluctuation. Figure 4-12 shows high-risk foods for disseminating foodborne illness. During preparation of food, we want to make sure that we keep food within that safe temperature range. So we want to cool it within 4 hours of cooking. It can be reheated within 2 hours before serving. And then while it's being served, employees need to use good personal hygiene and avoid cross-contamination. Now we come to sanitation. I always made a point to go into the dish room and really encourage the dishwashers that they were really the heroes of the department. They kept the germs from the hospital from going back up to the patients. And I think it really helped them to understand the importance of their jobs. Even though the pay wasn't the best, they were very important. And it's important that you help employees see that so they take pride in their work and realize their value. So here you see a 3-compartment sink, and each of the stages of cleaning the dishes are depicted here. So you sort, you scrape, you pre-rinse, then you go into the 3-compartment sink. Soak and wash, rinse, sanitize, and air dry. So one thing that could go wrong, sanitize. You really need a booster heater to get the sanitation sink up to temperature that would be enough to sanitize the dishes. Usually that's about 180 degrees. So what happens if your booster heater goes out? Then you have to be prepared to use some type of chemical sanitizing agent, whether that's bleach or some other type of chemical, which we'll see on the following slide. It's very important to have a backup plan. You also need a sanitizing schedule to sanitize equipment, the facilities, everything must be sanitized. And if you don't have a schedule, it'll fall through the cracks. You make assignments by personnel, who cleans what and when, and then your supervisor checks it. Here are the potential chemical sanitizers that you can use, and these are used in commercial food establishments. First off is chlorine bleach, and you have to be able to have a test strip to make sure that you have the right strength so that you don't have too much or too little. And there are a few other chemical sanitizers in use. Iodine is for one, quaternary ammonium compounds, organic acids. Now we talk about pest control. How do we control pests? Well, if you're in a commercial kitchen, you'll have a pest control program and probably a pest control company coming in to do this. It's very difficult to do this without a professional in such as a commercial kitchen. But some of the pests that we want to try to avoid are cockroaches, rodents, insects, and pantry pests. And how we do this is we block entrances, we block access to food, and of course, we run the pest control program. Now, blocking entrances would be, looking for cracks, looking for obvious places where pests could enter a kitchen. Also, sometimes you'll see an air curtain where when you have to open a door to the outside to either take garbage out or bring food in or whatever has to happen, never propping that door open. You have an air curtain that blows a very strong stream of air to prevent flying insects from coming in at that point. You've probably seen that. It's very effective. Okay, here's a discussion activity for you. A question is, what is the difference between sanitizing and sterilizing? Can pause the video at this point to discuss this. Jot down your notes, and then I will advance to the slide that will give you the notes from the textbook. Okay, moving on. Food safety monitoring. Food safety monitoring is conducted through state health department inspections. Violations can lead to license suspension or revocation. The FDA Food Code, introduced in 1993, provides a foundation for U.S. food safety, and this is updated every few years. Here's a typical health department inspection form. The categories: the food itself, food protection, personnel, food equipment and utensils, water, plumbing, toilet and hand washing facilities, garbage and refuse disposal, insect, rodent, and animal control, floors, walls, and ceilings, lighting, ventilation, dressing rooms, and then some other operations that may be an issue. One of those I'll point out: complete separation from living or sleeping quarters and laundry. There was a restaurant in Texas where I was in Waco teaching at Baylor, and there was a Chinese restaurant that we really thought we liked until we found out it was shut down permanently. They were doing their laundry in the kitchen and stringing it across the kitchen on clothesline. So they closed down. They never did reopen as long as I was out there. Lastly, we'll talk about the hazard analysis and critical control points, or HACCP. A HACCP plan is devised to address a potential hazard. So we're working with milk. We've identified the critical control point, which is the temperature. Okay, then we're going to establish a quantifiable limit, such as the temperature, the actual temperature. So we're saying 40 degrees or 41 degrees, depending on which you use, or lower. Now we need to monitor that critical control point. So we will monitor the refrigerator that it's stored in, but we also can monitor the milk itself. So that can be taken, like spot checks can be taken. Okay, let's say we're monitoring the refrigerator. So we're going to have a log, and at various points in the day, the supervisor will monitor that temperature and write it on the log. Okay. And then if there's a problem with that temperature and it's out of range, you take corrective action. You verify through regularly evaluating the records. So, let's say you notice the temperature for the refrigerator is out of range a couple times during the day. You have to look at why is that happening? Are people not shutting the refrigerator? Um, is there something wrong with the refrigerator? You have to figure that out. Then you verify through regularly checking those records ongoing, and you keep your documentation through this record keeping system. So that's just one example. You could have multiple HACCP plans going on, and probably would if you were in an institutional setting. Okay, so this is just a brief description of a HACCP plan, but it is a little bit more detailed than that. Okay, so in summary, we defined foodborne illness. We summarized major biological hazards. We explained the causes of food infections. We listed and described major food intoxicants. We identified and described bacterial, toxin-mediated infections. We compared and contrasted harmful chemicals and objects in food. We defined the differences between food allergy, intolerance, and sensitivity. We provided several steps in preventing foodborne illnesses. We did not cover the proper use of thermometers. That is a little bit more involved because there are many kinds of thermometers that can be used in a kitchen, and that is best described in your textbook. That concludes this lesson.